is what it looks like in all of its soldered glory. Everything's soldered up. That toroid, with the 5 turns, I did use the some of the Cat 5e cable. One of the problems I did find with it is it doesn't fit through the holes on the board unless you strip the insulation off. So if I go back in time, I could have made those holes for those pads a little bit bigger. But other than that, it worked pretty good. This one, I didn't do that. I just used an enamel wire for the primary and the secondary, but these two they're essentially identical. And then I got a pot soldered on here, the audio transformer, BNC connector. All these are test points that I put quite a number of test points on here so that if I need to hook up my oscilloscope or a voltmeter to specific points in the circuit, it would be a little bit easier. Completely unnecessary. But that's just something that I've kind of been doing in my circuits, is putting test points in. I think it really helps troubleshoot. And then I had 3D printed this a while back. This is the tuning inductor. I believe I printed it with support. I don't remember what kind. And but the inside of this tube was there was filament in there, I guess support. So I tried to kind of knock it out, and it was kind of hanging out the end of a little bit even. So I couldn't get that support to come out. So I took a drill bit, maybe like a 3/16 bit, something like that, and ran it in there. And just after a little bit, it kind of broke through, and it basically just pushed all that support out. And then the bolt went in perfectly, and I had to really force this in. Now I printed this at 110%. The instructions say if you're using standard instead of metric, 110%. That's what I printed it at. That nut there fits very tight. You're supposed to put a second nut here. There's no way I can get that in there. I mean, I would have to beat the thing till it broke. It wouldn't fit in there. So I don't know if maybe I should sand it a little bit or file it. I don't even really know that you need the second bolt. I mean, this seems to work pretty well with only one, or second nut. This seems to work pretty well with just one. It's pretty stable. I mean, I don't know. Hopefully it won't change the inductance much with that nut missing. It shouldn't. So, and this is 19 turns, and I'm using 26 gauge magnet wire. Same stuff I used before. That's what the instructions called for, or maybe the instructions called for 28. I don't remember, but I know in one of the videos I saw, the gentleman said you could use 26 or 28. It probably wouldn't make any difference. So I think so. I was kind of thinking about in the future maybe designing a board that you could mount this on top of somehow. But what I'm thinking now is that it might be better to actually 3D print a chassis, and then I could put some standoffs, put some holes in the board, and then screw the board down, and then screw this down. And I think and then it would kind of work as a unit. So I think I might, if this works by some miracle, I think I'll work on maybe redesigning this with some sort of a chassis or something. But anyway, I'm going to solder up the speaker because that's the only thing. Oh, and I'm going to solder this to the board. And that's the only thing that's left other than to hook it up to power, and hopefully nothing catches on fire. So we'll check back here in a minute. Okay, I think the first thing I'm going to do is check the current draw. I guess I'd rather do that than blow something up. I've got power supply that puts out about close to 14 volts. So it's a 12 volt power supply. Connected in series with my voltmeter. Got my voltmeter set on current. I have not turned this on yet. And when I say that, I really mean it. This is a channel where we don't we don't edit out too many of our screw ups here. So if it blows up, you're going to experience it with me. I know that would make for some really good entertainment, but I'm really hoping that nothing smokes here. So here we go. Seen a microamp there for a second. I don't know what's happening because we don't have. I'm going to shut that off. Maybe. And make sure everything's connected here. Everything seems to be connected. I hope I didn't hook it up backward. I'm going to go look at the board layout, but I'm pretty sure I had the positive was on the left side of that connector. Okay, I think I figured out. This is pretty weird, but it looks like this pin header here, the ground side, the pad is not connected to the ground plane correctly. It almost looks like the auto router ran a trace too close to that pad, and I couldn't really tell without spending some more time looking at it to see what was going on, but it had no continuity to anything. And that's kind of strange. I think I've ever had that happen on a board before, but that guess I'm going to blame the auto router for now anyway. I'm not sure if that's the cause, but I reflowed the pad, looked at the soldering, and I checked continuity every which way. So what I did was I moved the ground to this test connector where I was going to test voltage with. Luckily, it's almost kind of redundant. So, and then we'll power it on. And make sure everything's connected again. Something's not connected. Oh, evidently that's that cheap DuPont connector is not making very good contact. So yeah, it's wow, that's annoying. Those LEDs use quite a bit. I know that one there uses about 20 milliamps. The green one doesn't. See, there should be another one somewhere, I think. Yeah. It doesn't appear to be working. I can hear some static in the speaker. It's very, very, very quiet though, but there's something there. I don't think I don't think turning this would do any good at this point because it's not connected to an antenna. So I'm going to have to get something figured out where the power will stay more stable here. But I felt of it earlier. I mean, nothing seems to be getting hot. So that's a good sign. And again, the current draw seems a bit high, but those LEDs are pretty darn power hungry. Those I just happened to be kind of what I had. And I remember reading the data sheet, and I'm pretty sure that thing uses 20 or 30 milliamps. So the power usage here may not be too bad. The voltage regulator is just barely warm to the touch. I mean, I feel almost no heat from it. So I think I'm going to get this get this stabilized here and then check the battery voltage. And then from there, I'll probably check the oscillator to make sure it's running with my oscilloscope. And then And then, yeah, probably um, at that point, I think if everything seems to go okay, we'll probably connect it to an antenna and start trying to find a way to tune the bandpass filter and stuff. I don't have a VNA. I guess I could buy one. That might be part of this process too. So we'll check back.
So I wanted to show you what I did wrong here. There wasn't anything wrong. I can't, in good conscience, blame auto route for this problem, and I thought that I would just kind of share this with y'all just to show you that sometimes when you make boards like this, especially for, I mean, I have experience at it, but it's not something that I do on a daily basis. And I'm kind of powering through and expecting to make some mistakes like this. I want to get better at it. I want to get to the point where when I do design a board, it kind of works the way I wanted the first time, and there's kind of less of some of these silly mistakes. So when I connected power to this is the pin header where 12 volts comes in. I ground didn't seem to be working there, so I thought maybe there was something wrong with the trace around here, or the pad or something. But when I connect ground to this pin header over here, sorry, that's this is also part of the power circuit, or the power supply circuit. When I connected ground to this side, it worked. And this is VCC, and I couldn't connect the power and the ground here because this is VCC. This is V out from the voltage regulator, not V in. So, but the grounds are all kind of, they're common. So, well, I looked at the schematic for a couple minutes, and I noticed, I don't know why I done this. I think I got confused and just, I didn't notice this mistake. But so remember, pin 2 is ground. As you can see, pin 1 goes to the VN of this voltage regulator, which is going to knock that 14 volts back to 9.5 volts. Well, as you can see, coming from pin 2, follow that down here, we've got this 0.1 picofarad capacitor. I don't know why I put that there. That should have been tied. Well, first of all, I don't know why I would have used such a tiny value anyway. But there should have been like an electrolytic capacitor here on pin 1. So in other words, this should have been tied to here, and I may have made that mistake when I redid this circuit, or maybe it was just there from the beginning and I never noticed. So what's happening is when I connect ground to pin 2, there's a capacitor. so there's no continuity. So nothing on in the entire ground on the board. It can't get back to the actual ground coming in from the main power supply, from my bench power supply, because there's a capacitor in the way. And what I should have, I mean, first of all, just putting a ground there or a capacitor on the ground doesn't make any sense. But if you wanted to do that for some strange reason, even then, I think what I should have done, and I'm going to get in the habit of doing, I should have put the ground net right here at the very beginning. So if I wanted to connect it into some other component in the schematic, I again don't really know why I would. It should have been as close to the input on the schematic as possible, so I should have just dropped the ground net right there. So yeah, that there again, 2 mistakes. There shouldn't be a capacitor here. That should have been on pin 1. And that's just to knock off any ripples coming in from that benchtop power supply. It's really not necessary. But I like to build things in some similarities to how they would be built in the real world. So I again, that should have went to pin 1, and uh, ground should have been. This should have just went straight to ground. So that's just an example of, again, some of the mistakes you make when you do this stuff. I mean, luckily that was kind of a silly mistake, and so far I haven't found any other bad mistakes in this, in all this. But it's likely I've made another mistake somewhere, but we'll see.
Okay, so I've had a pretty tough go at it, to be honest. So I had the issues with the voltage regulator. Um, I, well, I had issues with the voltage regulator. The first one, there, I do not recommend buying components from Amazon or eBay or anything like that. I have very few left. Some of them that I bought years ago. I thought I had some name brand LM317 voltage regulators, but all I had was some Amazon stuff. So I went ahead and put it in there, and the thing just kind of stopped working while I was testing, and I couldn't figure out why. And then eventually I just jumped that voltage regulator with a new voltage regulator, and it started working again. So I thought I had that problem solved, and the next voltage regulator started to work intermittently. So that was pretty annoying. And by this time, I've kind of did a lot of desoldering on that part of the board, and um, I think the pads were still okay, but I just decided to bypass the voltage regulator completely and just go for a 9 volt battery. So I connected a 9 volt battery to it, and so that kind of got past my power problems. And the radio, you can hear the audio amplifier kind of crackle when it comes on, and then that's it. The audio amplifier doesn't oscillate, which is a good sign, but nothing else was really happening. And so I started checking voltages, trying to figure out what was going on. The first place I went to was the oscillator, and the oscillator was not running. Well, actually, I just checked it with my scope. I've got these test pins all over, and one of those goes to the kind of the center of the Colpitts oscillator, and or it goes. There's two transistors in that circuit. One is a BJT, and there's a JFET. There's a decoupling capacitor between those two transistors, or between those two parts of the circuit, and I was getting DC voltage kind of. So one side of that capacitor, and see this goes to like a JFET, right? And then this goes back to a BJT. This is coming off of the emitter of a BJT. I was getting DC voltage here, but well, not supposed to be getting any DC voltage on the other side, but wasn't getting any AC voltage either. And so I thought, well, that's really odd. I checked all the voltages; they all looked really good. I made sure there's a Zener diode in that circuit. I checked to make sure it was installed correctly and that it was good. I went around checking all the resistors, making sure they were the right values, checked all the capacitors for voltage, found DC voltage, no AC voltage whatsoever. And just, yeah, I was just really just kind of dumbfounded on what the problem could be. And what it ended up being was the wires coming off of this tuning inductor here, which is this magnet wire. I did not get enough of that enamel off, and it wasn't making a connection. And so I desoldered those, scrape, or actually burn them with a candle. And man, I don't know. The other brand of magnet wire I have is not like this. I mean, this stuff comes off like relatively easy, this stuff, man, this is like your super good magnet wire. Like I need to shout out to the brand name of this stuff because if you wind a transformer with it, I don't think you're going to get a short too easy. But so I put, after I scraped them, put them back in, fired it up, and we immediately started, the oscillator started to run. And I'll post a couple pictures up here, overlay, but is with the tuning inductor backed almost all the way out. We're running at like 7.02, I think, or somewhere. And then I turned it in a little bit more, and I watched it go up to, I think it was 7.25 megahertz. So just kind of playing around with it, making sure it was responding to the tuning, and that it was going to go the full range of the 40 meter band, and it certainly looks like it will. So that problem was solved. But you can imagine that if I had that problem with no electrical connection from those two magnet wires on this tuning inductor, that probably have some of those problems going on with these toroids. And in fact, I do believe that's the case, because I don't think I connected an antenna. I don't think anything is getting through the 40 meter bandpass filter. That's my guess. And so I went around. I turned the temperature on my iron up a little bit, and I went around to all the backside of these magnet wires on the board, trying to scrape and burn that enamel off, and it doesn't really look like it was coming off much more. And maybe there's just one in the whole bunch that's not making contact, and I don't know which one it is. And this happened over the course of like 30 minutes, well, not 30 minutes, but I mean, me trying to scrape the enamel off and kind of scratching my head, wondering what was going on after I'd got the oscillator to work. And so one of the pads is messed up. I think I don't remember which one of these toroids it is. I think it might be one of these two tri-fillers. One of them I've already had to jump to ground because one of the pads was messed up from where I tried to turn the temperature on my iron up and scrape it when that was the very first one that I'd done. So my frustration is kind of mounted here. I mean, I guess people are going to say I told you so. Maybe I should have did it Manhattan style, which is really, with my poor vision, is really hard to do. And I don't think I would have necessarily found it to be as rewarding either. But at this point, I just kind of took a deep breath, and I think the best thing I can do, because when I ordered these boards, I mean, I got 5 of them, and I don't really know what I'm going to do with the other 4. So I think the best thing for me to do is to just kind of step back, and I'll take the components off of this board that have any value. So basically the audio amplifier, I definitely want to save that, and the BNC connector, I'll probably pull that off. I'll probably just leave the toroids I'll probably cut those off because they're so easy to get off. I just cut them. The rest of the stuff I'll probably just leave on there because it doesn't really have any, it amounts to a few pennies worth of components, more or less. So, and then I'll just start over with a clean slate. And then while I'm at it, I'm going to use a different, instead of putting those pin headers, I've got this 2-pin wire connector. I'll just do that kind of from the get-go and connect it in such a way that I won't have trouble with that bad spot, or the spot, I won't say bad spot, but the mistake I made in the schematic. I think I can kind of right that wrong if I have a fresh board to start with, so that I can just plug this into my power supply and not have to worry about the 9-volt battery thing. So it's a little bit embarrassing and frustrating that the radio's not working yet, because I feel like it's really close. I didn't take I could use my signal generator, but I'm pretty sure the audio amplifier works fine, because I do hear that pop when I turn it on. And when I was probing this, the base of this JFET, which is the output of the Colpitts oscillator. Whenever I would probe it, the capacitance from my probe would kind of start some oscillations that would only last for about a half a second, but I could hear a bzz, 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 it coming out the speaker. So I do believe that the audio amplifier is okay. And I checked the schematic over and over and over too, trying to find a mistake that I made, hoping that I would find some mistake. And so far, I haven't been able to find one. Everything looks to be correct. So there's nothing I think better to do than to just hit the reset button and solder everything back up again and hope for a better result and learn from my mistakes on messing up those tri-fillers or the transformers. I don't know how I'm going to get that stuff off those magnet wires. I mean, I may just switch to the other wire that I have. It's larger, but I've never had trouble getting the enamel off of it, so I may just do that. But so yeah, I'll just post this up here, and we'll have to. Unfortunately, you and I both will have to wait to see a finished working receiver. Oh, and I did build. I haven't built an antenna in a long time. I built a 40-meter dipole. Checked it with my antenna analyzer. I didn't take any video of it, but and then I ordered these BNC adapters, so you can connect this to a PL259 to the BMC here, so that you can connect 50 ohm coax to it. Is the purpose of that. So because having a BNC connector is I didn't really think about it when I ordered it, but I was like, well, I don't have a way to connect an antenna to that, so I don't know. Maybe I should have just ordered, found some way to connect coax, or I don't know if they make a PCB mount one of these. I need to check into that. Something tells me that might be kind of hard to find, but I'll start when we go into the next video. I'll probably have some solder and pouring in there. So if you're not into that sort of thing, you might skip the first part of it, and then we'll come back and do some more checking. Hopefully we'll hear some Morse code if everything goes right. So we'll see you on the next one.